This is a very interesting question. When do two parametric functions intersect? So the first thing I'm going to do is take a look at the graph. So I've got it in parametric mode, and let me graph the first one first. So it's an ellipse, and the second one is also an ellipse going the other direction. So it looks like there's four places where they intersect. So that looks like it would be 45 degrees, which is pi over 4. So let me try and see if my intuition is right. Is it pi over 4? No. Is it pi over 2? No, even worse. Okay, so my guessing isn't really working right now, so I'm going to use my trig skills instead. So for these two functions to intersect, their x values would need to be the same, and their y values would need to be the same. So we've got basically two equations to solve. One is, when does that equal that? So 2 sine of t equals sine of 2t. And then right off the bat, we need the identity for sine of 2t is 2 sine of t cosine of t. And then it's tempting to divide out the sine of t, but if anything has a variable in it, you should not divide it out. You should instead move everything to one side. So I'm going to subtract this and move it to the left. And then that common thing that you're wanting to divide out, instead factor it out. That way, if it's ever equal to 0, you wouldn't be dividing by 0 ever. Because we're not dividing, we're factoring. So if you factor it out, it leaves a 1, and then the 2 got factored out, but not the negative. And then set each factor equal to 0. So 2 is never going to equal 0, but sine can. So when does sine of t equal 0? And then for this one, so when does cosine of t equal 1? And for these, I don't even need a calculator. Sine looks like this. So when it equals 0, is at 0 and pi and 2 pi. So t equals 0, pi, 2 pi. And then this one says, as well, you should consider when t equals, well, when cosine equals 1, that's at the top. So that's at 0 and 2 pi, which actually is not new information. I already have that, so thanks, cosine. Okay, now we still need to work with the y values, because this only makes the x values equal the x values, not the y values. So now I need to deal with the y values. Cosine of t equals 2 cosine of 2t. And then we start by using an identity for cosine of 2t. There's 3 to choose from, but there's only one of them that has cosine in it, only. So it's going to be, leave the 2 there, and for cosine of 2t, which is 2 cosine of t minus 1. And then distribute, so it's going to be 4, I left off a squared, 2 cosine squared of t minus 1 is the identity. And then distribute the 2, so it's going to be 4 cosine squared. I might as well move this over right now. Subtract cosine of t, and then distribute, so it's negative 2. And then use the quadratic formula, so cosine of t is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So cosine of t is equal to 1 plus or minus This is going to be positive, and it's an 8, 16 times 2 is 32, with 1 makes 33. And by getting a 33 in there instead of a perfect square, that tells me that this one over here would not factor, that I did actually have to use the quadratic formula. Alright, now I need some decimals. So it's going to be 1 plus the square root of 33 divided by 8. So cosine of t equals 0.843, or cosine of t equals, so do the same thing except with subtraction in here, negative 0.593. And now take cosine inverse. So cosine inverse of a 0.843, t equals 0.568, or cosine inverse of a negative 0.593 is 2.206 in radians. Alright, now in order, as I've said a couple of times, in order for these functions to intersect, the x has to equal the x and the y has to equal the y. Well, you can think of this t as time. So over here we said, when is the x going to equal the x? That's at the time 0 and pi and 2 pi. And when is the y equal to the y? That's at time 0.568 and 2.206. Now these don't match with these, which means that the x values can equal the x values, the y values can equal the y values, but never at the same time. If you take a look at the graph, you then say, wait a second, I just saw it intersect right there. But these are parametric equations where time actually matters. So imagine that one airplane was flying like this, while the other airplane was flying like this, like they were at an air show or something. Did they get to the same place? Yes. More important, did they get to the same place at the same time, thus causing a tragedy? And this is saying they might have gotten to the same place, but they got to that at different times. So there's no solution. One other thing you can do with the graphing calculator to visualize this is, I'm going to regraph it, but on the mode, use simultaneous. So think of these as two airplanes flying through the air simultaneously, and do they get to the same place at the same time? And then another thing I'm going to do is change the t step to be something fairly small, like 0.05, and then that'll slow it down so it'll graph more slowly and we can watch. And then it's going to graph both of them and see, do they ever get to the same place at the same time? So their paths do cross, but they're at different places when that happens.